Hi, this is Paul from Foresight Tech. In this video, I will introduce a formula to find the time for doubling time growth model. Here is the formula we call time formula. To find the time needed to reach a value, we have to solve the doubling time growth model, which is this one we learned before, 4t. Okay, and after you solve this equation, you will find the time formula, which is here. And the first one, we use ln, which is natural logarithm. And if we change the natural logarithm to lg, which is the common logarithm, and the value is still the same. So you can use the first or the second. It's exactly the same you will get. Now, let me draw a graph to show you the meaning. And if this is the time, okay, if this is the y value or population, okay, and this point is the initial value, p0. If we know the doubling time growth model, okay, let me draw the graph. Okay, see, goes up. We know the model means we know the doubling time, right? Let me put here the doubling time TD we know. The initial value, of course, we know. And then, see, given any future value, of course, let me put here, called PT. Okay, because the doubling time growth model grow up into infinity. Okay, definitely there is a time. Sometime later, the model can reach PT, right? How to find the t, the time needed? We can do this way. See, we draw a horizontal line. Can we see? We can find a unique time here. Okay. But how to find the time? That's the question. Okay. How do you find the time the model needed to reach the future value PT? Okay. Of course, this PT you should given. Where is the formula? We just see either this one or this one. And I will prove this formula at the end of this video. But first, we need to practice this formula. Here is the first question. Suppose that a bacteria population doubles every 6 hours. Therefore, there's a doubling time growth model, right? If the initial population is 4,000 individuals, how many hours would it take the population to increase to or go beyond 25,000? Okay, look at the questions. How many hours it need? Therefore, we need the time formula, right? So let me cover the time formula first. The time formula, which is this: time t equals big fraction. Okay, numerator is td, doubling time, times ln at pt future over p0 initial. The denominator is ln at 2. Let me highlight. All we need is this formula. Okay, now we plug in all the parameters. First was td, 6 hours, right? Okay, so this is the doubling time. Okay, and then 4,000 is initial population, which is p0. So we have p0. What is the pt? Okay, reach 25,000. That's pt, the future value. See, we know everything. Now we plug all the value into the formula. So let's set up. Therefore, t equals this fraction. Td is 6 hours, right? Times ln at future value 25,000 over initials 4,000. Okay, the denominator is ln at 2. ln we call the natural logarithm. Now, let me show you how to find the logarithmic functions in the calculator. Now, let's evaluate. So, 6 times ln natural logarithm, which is here on the left side, ln. Okay, now we type out the number. Don't miss the parentheses. That's the numerator, right? And then divided by the denominator is ln at 2. ln here at 2 parentheses. Enter. See, we get the value, which is 15.86. That's the answer, right? Do you remember the time formula? We do have another version. We use a log, common logarithm. Where is the common logarithm? I'll show you here on the left side also. Okay, let's go to evaluate it. So you will find the same answer. Okay, so 6 log, type the number, parentheses, and then divided the denominator, which is also log, added 2 parentheses. Enter. See, the answer is exactly the same. Okay, now let's go back. Let's put the answer here. Okay, so it's around 15.86 hours, right? Okay, if the question asks the integer hours, how many hours do we need? We need 16 hours. Okay, therefore 16 hours needed. So here is a little special. It's not because of 15.8 we round up. Okay, because what we round up? Because we need more than 15 hours to reach or go beyond this population. Therefore, how many hours do we need? We need 16 hours. Okay, even you get the answer is 15.1 hour, even like this, you still need to round up. Okay, you still need to round up. Okay, if the question asks you to round to the nearest integer, of course, and then you follow. If the question did not say that, you always round up. So this question is 16 hours needed. Let's practice one more question. Here is the second question. A certain cancer tumor doubles in size every 3 months. If the initial size of the tumor is 4 cells, how many years would it take the population to increase to or go beyond 1 million cells? Okay, that's a doubling time growth model because it doubles every 3 months. Okay, so the question asks how many years, therefore is the time formula we need. Let me copy the time formula again, which is T equals, right, is doubling time TD times ln at PT future over P0 initial over ln at 2. Okay, again, let me highlight. Now, we're going to find the parameter. What is TD? TD says 3 months. Okay, so this is TD. And what is PT? The future value, reach or go beyond 1 million. That's a PT. See, so we have PT, we have a TD. Now, do we have a P0 initial? Yes, 4 cells. Okay, so this is a P0. We do have. Okay, and then we plug everything in. Okay, so we find the answer. But one I have to mention, TD is in 3 months. And the question they ask how many years. Okay, the unit is not consistent. Okay, you can do this. You can change the years to month or change the month to year. So let's keep the month first. Okay, we're going to find the t in months first. Therefore, we plug everything now. Set up a t. So t equals td now is 3 months times ln add okay a million the future over 4 cells the initial divided by ln at 2. Okay, do calculation in the calculator. See what do we get? We will get this about 53.79. What is the unit? And the unit is months, right? So let me highlight this. The unit is month because we use the doubling time t as months. Okay, keep in mind that now we have to change the month to years, right, to find the answer. And therefore we're going to, so t equals 53.79 divided by 12. Okay, you do calculation. See what do we get? We get 4.48. Okay, so now the unit is years. That's the one we need. If you need integer years, do you think is 4 years we need or 5 years we need? Okay, so here keep in mind, which means 5 years needed. We just said the reason, right? Because more than 4 years, more than 4 years, you know. Okay, so that's this question. Now let's practice. Let's prove the formula. How do you prove? Let's start from the doubling time growth model. Okay, so I copy the formula here first, which is pt equals p0 times 2 raised to the power of t over td, right? Can you see which parameter we need? Time. So from here we have to solve this equation, find what is the time. We solved this type of equation before, and this is we call the exponential equation, right? Exponential equation. Okay. Let's do. So the first step, I have to divide it by p0 to the right, divide it by p0 to the left. Okay, so I can cancel p0. Therefore, I will get this a little bit simple one. So the left is pt over p0. The right is 2, the base, raised to a power of t over td. Let me highlight this variable again. We need to solve for t. Now, okay, we simplify this power, okay, by taking logarithm. I take ln, natural logarithm, to the left. Okay, I take ln, natural logarithm, the same to the right. Therefore, so they are the same. I put in, so the left is pt over p0. The right is 2 raised to the power of t over td. Again, let me highlight. Okay, so now, and then we do have a complicated power, right? So for natural for logarithm, we do have a power rule. Okay, I can take this power down to simplify. Okay, and therefore, what do we have? We will have this. The left is ln at pt over p0. Now the right, which is t over td after take the power down, times ln, see, add 2. Okay. Let me put the power rule formula here. So to remind you what we used, we used the power rule of logarithm, which is this ln at a raised to the nth power equals, okay, n times ln at a, which means this power can take it down. Okay. Now, again, let me highlight the variable t we need to solve, right? So how to do? I can simplify a little by cross multiply. I can times the denominator td to the right. So I times the denominator td to the left. And we can simplify this by cancel. Now, we still need to solve for t, right? We don't need the ln at 2. So I divided it by ln at 2 to both sides of the equation, which is this, divided by ln at 2 to the both sides. So I cancel this one. See, we do solve it for t, right? Now let me put down the answer. So what do we have? We have t equals a fraction, okay, td times ln at pt over p0, ln at 2. Let me highlight. This is the formula. Do you remember? It's exactly the same. Okay, so that's the proof. If somewhere you want change this natural logarithm to common logarithm log, therefore we will have another version, change ln to log, right? Okay, so that's all. Thank you.